Now let's go through exercise 13.2. First question. If probability of A is equal to 3 by 5 and probability of B is equal to 1 by 5, find probability of A intersection B if A and B are independent events. Here it's given if A and B are independent events, then what is the value of probability of A intersection B? Okay. So we know that probability of A intersection B is equal to probability of A into probability of B if A and B are independent events. Okay, it is given. Since A and B are independent events, then probability of A intersection B is equal to probability of A into probability of B. Substitute the values of probability of A and probability of B. That is 3 by 5 into 1 by 5, that is equal to 3 by 15. That is 1 by 5. Since A and B are independent events. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. Okay, so from 52 cards, two cards are drawn at random without replacement. Okay, see, first of all we should know how many black cards are there. So there are 26 black cards out of 52 cards, right? So here, first of all, let's take the event. See, we have to find the probability that both cards are black. Okay. So here, first of all, let E be the event. First card drawn is black. Okay. Let F be the event. Second card drawn is black. Okay. Now, since it is without a replacement, these two events are dependent events, right? Therefore, okay, first of all, let's write what is probability of E. Probability of E, it is the probability of first card drawn is black. Okay, so we are selecting one card from 52 cards. That is probability of E. That is nothing but, see how many black cards are there? 26, right? So 26 divided by total number of cards, that is 52. That is equal to 1 by 2. Right? Next, we will find that is probability of second card drawn is black. That is probability of F from which we select without a replacement. Right? So one card is reduced. Therefore, here probability of F given that E has already occurred. Okay, that is the event E has already occurred. So here we selecting the card from here. Okay, so one card is reduced. Therefore, it is probability of F given that E. Okay, probability of F given that E. That is equal to, now how many black cards? 25. Right? So 25 divided by how many total cards? 51. Okay. Now what is the formula? See, we have to find the probability that both the cards are black. Means both these cards. Okay. Probability of these two events. These two events occurring together. That is probability of E and F. That is nothing but probability of E intersection F. This E intersection F indicates the event that both E and F have occurred. Okay. So here probability of E intersection F, that is equal to probability of E into probability of F given E. Okay. F given E. Understood? Because it is without replacement. Therefore, both the events are dependent events. Don't be confused. If it is without replacement, then given events are dependent events. Therefore, it is the formula. Okay. That is equal to, substitute, probability of E is 1 by 2 into probability of F given E is 25 divided by 51, that is equal to 25 divided by 102, right? A box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. If all the 3 oranges are good, the box is approved for sale. Otherwise, it is rejected. So find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for sale. So here, see, there are 15 oranges. Out of 15 oranges, 12 are good and 3 are bad. So here we have to find the probability of, so it is given 3 oranges. If 3 oranges are good, then the box is approved for sale. Okay. So here we have to find the probability of approved for sale. Okay. That means probability of 3 good oranges are drawn. Okay. 3 good oranges are drawn. So here for that, let's take, let E be the event selecting a good orange. Okay, selecting a good orange. Here 3 oranges are drawn at random without replacement. Okay. Now let's take the event selecting a good orange. Why? Because here we have to find the probability of 3 good oranges are drawn. That is, see, it is given, it will be approved for sale. And we know that if 3 oranges, drawn oranges are good, then only the box is approved for sale. Right? Okay. So here E be the event selecting a good orange. Now what is probability of E? Probability of E is, see how many total oranges are there? Total oranges 15, there are 15 oranges, total oranges, right? And how many good oranges? 12, right? So therefore, probability of E is equal to 12 divided by 15. Okay. Now here, let's take good oranges. So it is better to take G, okay? G be the event selecting a good orange. And here, see, we are selecting good 3 oranges, right? That is, we have to find the probability of 3 good oranges, right? So let's name it as G1, G2, G3. Okay. Now it is probability of G1. Okay. That is selecting first orange. That is probability of first orange. That is 12 divided by 15. There are total 12 good oranges and there are total 15 oranges. Okay. So 12 divided by 15. And it is given that 3 oranges are drawn without replacement. Okay. Without replacement. Therefore, here 1 orange is reduced. Okay. After selecting 1, then for second one, 1 orange is reduced. Right. So therefore, what is probability of G2 next? Probability of G2 given selecting from this G1, right? Given that G1 has already occurred. Therefore, probability of G1 given G2 given G1 is equal to 1 is reduced, right? So that is 11 divided by, now what is the total oranges? 14. Okay. Next 3 oranges, right? We have to select 3 oranges. So probability of 3 good oranges. So here next is probability of G3 given that G1 and G2 has already occurred. That is G1 intersection G2. That is equal to, now 2 oranges are reduced. Okay. So here we are selecting from this. Okay. That is here G1, G2, G3 are dependent events because it is without replacement. Okay. Now G3 given that G1 intersection G2, that is 10 divided by 13. 10 divided by 13. Now what is the probability? Probability of G1, G2, G3 is equal to probability of G1 into probability of G2 given G1 into probability of G3 given G1 intersection G2. Right? Since 3 oranges are drawn without replacement. Okay. Therefore, these events are dependent events. Therefore, this is the formula. G1, G2, G3. Probability of G1, G2, G3 is equal to probability of G1, probability of G2 given G1, probability of G3 given G1 intersection G2. So here probability of G1 is 12 by 15 into 11 by 14 into 10 by 30. Okay, calculate and find the answer. That is equal to 44 by 91. Okay, 44 divided by 91. A fair coin and an unbiased die are tossed. Let A be the event head appears on the coin and B be the event 3 on the die. Check whether A and B are independent events or not. For independent events, we have to check probability of A intersection B is equal to probability of A into probability of B or not. If probability of A intersection B is equal to probability of A into probability of B, then A and B are independent events. Okay, so what is the experiment? A fair coin and an unbiased die are tossed. So what are the possible outcomes? Sample space H1, H2, H3, H4, H5, H6. Next T1, T2, T3, T4, T5, T6. Okay. Now here given that A is the event head appears on the coin. So what are the possible outcomes of A? Head appears on the coin, that is H1, H2, H3, H4, H5, H6. Next, B is the event 3 on the die. So what are the possible outcomes? H3, T3, right? H3, T3. Now let's write intersection of these two events, that is A intersection B is equal to H3 is common, right? So H3. Now let's find the probability of A intersection B, probability of A and probability of B. So what is probability of A? Number of elements in A divided by number of sample space, that is 6 divided by 12 is equal to 1 by 2. Next, probability of B, how many elements? 2 divided by number of elements in the sample space 12, that is equal to 1 by 6. What is number of elements in A intersection B? Only 1, right? So probability of A intersection B is 1 divided by 12, right? So that is 1 by 12. Now here probability of A into probability of B, that is equal to 1 by 2 into 1 by 6, that is equal to 1 by 12, that is equal to probability of A intersection B. Right? Now we have got probability of A intersection B is equal to probability of A into probability of B. Therefore, A and B are, hence A and B are independent events. A die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the event, the number is even, and B be the event, the number is red. Okay. Are A and B independent? So here also we have to check whether probability of A intersection B is equal to probability of A into probability of B or not. Okay. Now, so here first of all let's write the sample space. What are the possible outcomes of this experiment? See here a die is tossing. Right? So what are the possible outcomes? 1, 2, 3, 4, 5, 6. Right? And here see let's write the possible outcomes of A and B. possible outcomes of event A are, say, A be the event, number is even. Okay, so what are the even numbers? 2, 4, 6, right? 2, 4, 6. And B is the event. What are the B is the event? The number is red. So what are the possible outcomes? Number is red. Here it is given 1, 2, 3 are marked in red. Okay, so 1, 2, 3. Now let's find what is A intersection B. A intersection B is 2, right? Only one element, that is 2. Now let's find probability of A. What is probability of A? 3 divided by 6, that is 1 by 2. Probability of B, 3 divided by 6, number of sample space, that is 1 by 2. And what is probability of A intersection B? That is 1 divided by 6. Then here probability of A into probability of B is equal to 1 by 2 into 1 by 2, 1 by 2 into 1 by 2, that is 1 by 4. But probability of A intersection B is 1 by 6. It is not equal to probability of A intersection B. Right? Therefore, A and B are not independent events. Okay, here A and B are not independent events because we have got probability of A intersection B not equal to probability of A into probability of B. Let E and F be events with the probability of E is equal to 3 by 5, probability of F is equal to 3 by 10 and the probability of E intersection F is equal to 1 by 5. Are E and F independent? So here given that probability of E is equal to 3 by 5, probability of F is equal to 3 by 10 and probability of E intersection F is equal to 1 by 5. Now let's find probability of E into probability of F, that is equal to 3 by 5 into 3 by 10, that is 9 by 50, right? But here what is probability of E intersection F? 1 by 5. So it is not equal to probability of E intersection F, right? Hence E and F are not independent. Given that the events A and B are such that probability of A is equal to 1 by 2, probability of A union B is equal to 3 by 5 and probability of B is equal to P. Find P if they are, first one, mutually exclusive. If they are mutually exclusive, then what is the value of P? See, what are the mutually exclusive events? See, two events are said to be mutually exclusive events if they cannot occur at same time or simultaneously. Okay, that is, they are disjoint events. See, if A and B are mutually exclusive events, then probability of A and B or A intersection B, that is equal to 0. Okay, that is probable because they are disjoint, right? So A intersection B is a null set. Therefore, probability of A intersection B is equal to 0. Okay. Now here, if they are mutually exclusive, then what is the value of P? So here, we know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay. Here first case, A and B are mutually exclusive. If A and B are mutually exclusive, then probability of A intersection B is equal to 0. Right? Because they are disjoint. Okay. Now, therefore, why this probability of A intersection B is equal to 0? A intersection B is equal to null set because A and B are mutually exclusive. Okay. Since A and B are mutually exclusive, A intersection, probability of A intersection B is equal to 0. Therefore, probability of A union B is equal to probability of A plus probability of B. It is 0. Right? Now, let's substitute probability of A union B. It is given 3 by 5. That is equal to probability of A is 1 by 2. Probability of B is P. Right? That implies P is equal to, take this 1 by 2 here. So, 3 by 5 minus 1 by 2. That is 6 minus 5 divided by 10. Right? That is 1 by 10. So here P value is 1 by 10. Okay? If A and B are mutually exclusive, then P is equal to 1 by 10. Next, second case, if A and B are independent events, then what is the value of P? We know that if A and B are independent events, probability of A intersection B is equal to probability of A into probability of B. Okay? Now, we need to find the probability of A intersection B. Right? In second case, if A and B are independent events, then what is the value of probability of A intersection B? It is given probability of A union B. Right? So, from this formula, we can find probability of A intersection B is equal to probability of A. Okay, from this formula, probability of A plus probability of B minus probability of A union B. Right? That is equal to probability of A is 1 by 2 plus P minus 3 by 5. Okay. So, here what is probability of A intersection B? Yes, probability of A intersection B is equal to, that is, let's take the LCM of these two terms. Okay. So, 5 minus 6 divided by 10 plus P, that is equal to minus 1 by 10 plus P. It is probability of A intersection B. Now, let's find probability of A into probability of B. Okay. So, here it is given these two events are independent. Therefore, let's substitute this one, probability of A intersection B is equal to probability of A into probability of B. Right. Therefore, probability of A intersection B is P minus 1 by 10, that is equal to probability of A is 1 by 2 into probability of B is P. Okay. So, this implies that is equal to P by 2. Right. Next, let's take this P by 2 left side. So, it will be P minus P by 2 is equal to, take this minus 1 by 10 right side. So, 1 by 10. Okay. So, it is equal to, that implies 1 minus 1 by 2, that is 1 by 2. So, P by 2 is equal to 1 by 10. That implies P is equal to 2 cancelled. So, 1 by 5. Okay. If A and B are independent events, then value of P is 1 by 5. If A and B are mutually exclusive, then P value is 1 by 10. P value is equal to, yes, P is equal to 1 by 10. Let A and B be independent events with the probability of A is equal to 0.3 and the probability of B is equal to 0.4. Find probability of A intersection B. Okay, first of all, let's find probability of A intersection B. We know that, see, here it is given A and B are independent events. Okay, if A and B are independent events, then probability of A intersection B is equal to probability of A into probability of B. Right? That is equal to, what is probability of A? 0.3 into probability of B is 0.4, that is equal to 0.12. Right? Next, second one, we have to find probability of A union B. Probability of A union B, formula is probability of A plus probability of B minus probability of A intersection B. That is equal to probability of A is 0.3 plus 0.4 minus 0.12. That is equal to 0.7 minus 0.12, that is 0.58. Right? Next is third one, probability of A given B. That is probability of A intersection B, conditional probability formula. Probability of A intersection B divided by probability of B, that is equal to probability of A intersection B is 0.12 divided by probability of B is 0.4, that is equal to 0.3, right? Next, fourth one, probability of B given A, that is equal to probability of A intersection B divided by probability of A. Probability of A intersection B is 0.12 divided by probability of A is 0.3, that is equal to 0.4. If A and B are two events such that probability of A is equal to 1 by 4, probability of B is equal to 1 by 2 and probability of A intersection B is equal to 1 by 8, find probability of not A and not B. See how to write not A and not B? Probability of not A means A complement, right? And intersection not B, B complement, right? So this one we have to find. Probability of A complement intersection B complement. So first of all, let's write what are given. Probability of A, that is equal to 1 by 4, probability of B, that is equal to 1 by 2 and probability of A intersection B is equal to 1 by 8. So here probability of A into probability of B, that is equal to 1 by 4 into 1 by 2, that is equal to 1 by 8, that is equal to probability of A intersection B. So here we have got probability of A intersection B, that is equal to probability of A into probability of B. Therefore, A and B are independent events. Okay. Hence, A and B are independent events. Since A and B are independent events, their complement are also independent events. Okay. That is, since A and B are independent events, hence A complement and B complement means not A and not B. Okay. A complement and B complement are also independent events. Since A complement and B complement are independent events, we can write probability of A complement intersection B complement is equal to probability of A complement into probability of B complement. Why? A and B are independent events. Okay. Therefore, probability of A complement intersection B complement, that is equal to probability of A complement into probability of B complement. So here, what is probability of A complement? That is 1 minus probability of A. I have already mentioned in the introduction and we studied in 11th standard also, right? So 1 minus P of A, that is probability of A complement is equal to 1 minus probability of A. And probability of B complement is equal to 1 minus probability of B. That is equal to 1 minus probability of A is 1 by 4 into probability of B is 1 minus 1 by 2. Okay. That is equal to 3 by 4 into 1 by 2. Right. That is equal to 3 by 8. So here probability of A complement intersection B complement is equal to 3 by 8. That is probability of not A and not B is equal to 3 by 8. Probability of A complement is nothing but not A, right? So not A and not B is equal to 3 by 8. Events A and B are such that probability of A is equal to 1 by 2, probability of B is equal to 7 by 12 and probability of not A or not B is equal to 1 by 4. State whether A and B are independent. So here for independent we have to check whether probability of A intersection B is equal to probability of A into probability of B or not. So here, so first of all let's write what are given. Probability of A is equal to 1 by 2. Probability of B is equal to 7 by 12. and probability of not A, that is A complement, or refers to union. Okay, so remember, or refers to union and refers to intersection. So here A complement union B complement. Okay, that is equal to 1 by 4. So here we know that probability of A complement union B complement is equal to probability of A intersection B whole complement by the property of complement of sets, right? That is equal to, here see we know that probability of E complement is equal to 1 minus probability of E, right? So this can be written as 1 minus probability of A intersection B, right? So here, what is probability of A intersection B? Take this probability of A intersection B here. Probability of A intersection B is equal to, take this one right side, 1 minus probability of A complement union B complement. That is equal to 1 minus, it is 1 by 4. That is 3 by 4. Now what is probability of A into probability of B? Probability of A into probability of B is equal to 1 by 2 into 7 by 12, that is 7 by 24. Right? So here we have got probability of A intersection B is 3 by 4. Therefore here probability of A intersection B is not equal to probability of A into probability of B. Okay? Since probability of A intersection B not equal to probability of A into probability of B, A and B are not independent events. Given two independent events A and B such that probability of A is equal to 0.3, probability of B is equal to 0.6, find probability of A and B, probability of A and not B, probability of A or B, probability of neither A nor B. So first one, probability of A and B, and refers to the intersection, right? So probability of A and B can be written as probability of A intersection B. And here it is given that A and B are independent events. Therefore, probability of A intersection B is equal to probability of A into probability of B. These values are given 0.3 into 0.6, that is equal to 0.18. Next, second one, probability of A and not B, that is equal to probability of A and intersection not B, means B complement, right? B complement. And here we know that if A and B are independent events, then their complements A complement and B complement are also independent events. Therefore, A and B complement are also independent events, right? Therefore, this can be written as probability of A into probability of B complement. Okay. Now, probability of A into, how can we write probability of B complement? That is 1 minus probability of B, right? That is equal to probability of A is 0.3, 1 minus probability of B. Probability of B is 0.6, so 1 minus probability of B is 0.4. That is equal to 0.12. Third one, probability of A or B. Or refers to union, right? Therefore, probability of A union B, that is equal to, what is the formula? We have a formula, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. That is equal to probability of A is 0.3 plus 0.6 minus probability of A intersection B is 0.18. 0.3 plus 0.6, 0.9, 0.9 minus 18 is 0.72, right? Next, fourth one, probability of neither A nor B, that is equal to, here see probability of neither A means A complement, okay, nor B, B complement. that is intersection. Okay, neither A means into, okay, multiplication, A complement and B complement and B complement. Okay, therefore probability of A complement intersection B complement. So here A complement and B complement are independent events, therefore probability of A complement into probability of B complement, that is equal to 1 minus probability of A into 1 minus probability of B, right? That is equal to 1 minus probability of A is 0.7. Probability of A is 0.3. 1 minus 0.3 is 0.7. Into 1 minus probability of B. Probability of B is 0.6. So 1 minus 0.6 is 0.4. That is equal to 0.28. A die is tossed thrice. Find the probability of getting an odd number at least once. See here, the experiment is a die is throwing 3 times. Okay. So here we have to find the probability of getting an odd number at least once. See, when we throwing a die 3 times, what is the sample space? The sample space is 111, 112, 113, etc. 611, 612, right? There are 216 possible outcomes in this sample space, right? So here we have to find the probability of getting at least one odd number. Okay, that means, see, for example, 3, 2, 4 or 3, 1, 5, okay, and 6, 1, 5, right? So here see, 1 odd number, here 3 odd numbers, here 2 odd numbers, right? But it is not 2, 4, 6 or 6, 2, 4. These are not possible. Okay? That is, we have to find the probability of an odd number, getting an odd number at least once. Okay. So here, first of all, let's write what is the probability of getting an even number when one die is thrown. See, when one die is thrown, what is the sample space? 1, 2, 3, 4, 5, 6. Right? So, in these numbers, what are the even numbers? 2, 4, 6. 3 numbers, right? So, here probability of getting an even number when a die is thrown is 3 by 6. That is 1 by 2. Right? So, probability of getting an even number when a die is thrown is equal to 3 by 6, that is 1 by 2. Then what about odd numbers? See, odd numbers 1, 3, 5. That is also 3 number, right? So 3 divided by 6. Probability of getting an odd number when a die is thrown is 3 by 6. That is also 1 by 2. So probability of getting an odd number when a die is thrown is equal to 1 by 2. Right? Now, what we have to find? We have to find probability of getting an odd number at least once. See here, probability of getting an odd number at least once is equal to probability of not getting even number in all the three throws, right? Yes or no? Here, see, probability of getting an odd number at least once means, see, probability of not getting even number in all the 3 throws. Okay, that is, for example, suppose here 2, 4, 6. Okay, what is its complement? Its complement is at least one odd number, right? At least one odd number. So here, now we can find the probability of getting even number in all the 3 throws, right? So that we can take its complement. So that its complement is nothing but this required probability, that is probability of getting an odd number at least once. Okay, so here that is 1 minus, see, probability of not getting even number in all the 3 throws means 1 minus probability of, it is the complement, right? Complement of probability of getting even number in all the 3 throws, right? That is probability of getting even number in all the 3 throws. Okay, that is equal to, see how to find in all the 3 throws getting even number. Okay, that means, okay, first throw even number. So what is the probability? Here, see, in all the throws, here not replacing, without replacing nothing at all. But here we can understand, see, these events are independent events. Okay, see, first you throw a die, then what is the probability of getting even number? 1 by 2. Next time you throw the dice, okay, so what is the probability of getting an even number? 1 by 2. Third time you throw the die, so what is the probability of getting an even number? 1 by 2. Right? Therefore, probability of getting even number in the all the 3 throws is nothing but 1 by 2 into 1 by 2 into 1 by 2. Right? That is 1 minus, here probability of getting even number in all the 3 throws is 1 by 2 into 1 by 2 into 1 by 2. Right? That is equal to 1 minus 1 by 8. That is equal to 7 divided by 8. So here probability of getting an odd number at least once is 7 by 8. Okay, because see here we cannot find this one directly. Okay, therefore here we can find probability of getting even number in all the 3 throws. That one we can find. So take its complement. Its complement is nothing but probability of getting an odd number at least once. Right? So here probability of not getting even number in all the 3 throws. Okay, that is equal to this one. So it is nothing but it is the complement of getting an even number in all the 3 throws. Right? That is complement means we know that probability of A complement is 1 minus probability of this one. Probability of A. Right? So 1 minus probability of getting even number in all the 3 throws. And we know that probability of getting an even number when a die is thrown is 1 by 2. Okay. So probability of getting an even number in all the 3 throws is 1 by 2 into 1 by 2 into 1 by 2. Okay. That is 7 by 8. So probability of getting an odd number at least once is 7 by 8. Two balls are drawn at random with replacement from a box containing 10 black and 8 red balls. Find the probability that both balls are red. Second, first ball is black and second ball is red. One of them black and other is red. Okay. So here 2 balls are drawn at random with the replacement. Okay. So events will be independent. Right. Okay. Now first of all let's take the event R be the event red ball is drawn. B be the event black ball is drawn. Okay. Now here what is the probability of R? Probability of R, how many red balls? 8 red balls out of 18 balls. Right? Therefore 8 divided by 18 that is equal to 4 by 9. Next, probability of B. What is the B? B is the event black ball is drawn, right? So, how many black balls? 10 black balls out of 18 balls. That is 10 by 18 that is equal to 5 by 9. Okay. So, first question is both balls are red. Okay. That is probability of both balls are red means probability of first ball is red, second ball is red. Okay. Both balls are red. That is probability of first ball is red, second ball is also red. That is equal to probability of R into probability of R. Because here events are independent. Okay. Here See, first when we select one ball and replacing it back. Okay. Therefore, events are independent. Therefore, probability of R, that is R intersection R, that is equal to probability of R into probability of R. That is 4 divided by 9 into 4 by 9, that is equal to 16 by 81. Next, second one. Here, first ball is black, that is probability of first ball is black and second ball is red. So, probability of first ball is black and second ball is red. That is equal to probability of B, probability of R. Since events are independent, probability of B R is equal to probability of B into probability of R. That is equal to, what is probability of B? 5 by 9 into 4 by 9. That is equal to 20 divided by 81. Next, third one of them black and other is red. See, in third one, it is not mentioned that which is first one and which is second one. Right? So, here two possibilities are there. One is first ball is black, second is red. And or first is red, second is black. Okay? So, two possibilities. So, probability of one of them black and other is red, that is equal to probability of first ball is black. If first ball is black, second is red. Or first ball is red, second is black. Right? Now here, that is first ball is black, second is red, means probability of B R. Right? Or plus, okay, probability of first ball is red, that is probability of R B. That is equal to probability of B R, that is nothing but probability of B into probability of R. Probability of B is 5 by 9 into probability of R is 4 by 9 plus again probability of R into probability of B. Probability of R is 4 by 9 into 5 by 9. That is equal to 20 by 81 plus 20 by 81, that is 40 divided by 81. Probability of solving specific problem independently by A and B are 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is solved. Second, the probability of exactly one of them solves the problem. Very, very important question. So here, first of all, let A be the event. Problem is solved by A. Problem is solved by A. Okay. And B be the event. Problem is solved by B. Okay. Now, what is probability of A? Probability of A, that is problem solved by A, that is 1 by 2, right? That is equal to 1 by 2 and probability of B is equal to 1 by 3. Now here we have to find the problem is solved. Okay, probability of problem is solved. Okay, A, that is probability of problems is solved by A or problem is solved by B. A or B. Or here we can write, that is, see, this one can be written as probability of the problem is solved. The problem is solved is equal to complement of probability of none of them solves the problem. Okay, that is how to write complement, that is 1 minus, right? That is, we know that probability of A is equal to 1 minus probability of A complement, right? So 1 minus probability of none of them solves the problem, right? So here the problem is solved is, that is equal to 1 minus probability of none of them solves the problem. So here we can find this one, right? That is 1 minus, what is this one? Probability of none of them solves the problem is probability of A complement, right? B complement. Okay, that is here problem is solved by A means probability of A, right? And problem is solved by B means that is probability of B. Okay, but here none of them solves the problem. Therefore, it is probability of A complement B complement, right? That is equal to 1 minus probability of A complement into probability of B complement, because here it is given A and B are independent. Okay, therefore A complement and B complement are also independent. That is equal to, now we can find 1 minus probability of A complement. Probability of A is 1 by 2. So probability of A complement is 1 minus 1 by 2, that is 1 by 2. And here probability of B complement is 1 minus 1 by 3, that is 2 by 3, right? So 2 by 3, that is equal to 1 minus 2 by 6, that is equal to 4 by 6, that is 2 by 3. Okay, so here probability of the problem is solved, that is equal to 2 by 3. One card is drawn at random from a well shuffled deck of 52 cards. In which of the following cases are the events E and F independent? First one, E is the event card drawn is a spade. F is the event card drawn is an ace. Okay. So here we have to check whether this E and F independent or not. So for that we have to check whether probability of E intersection F is equal to probability of E into probability of F or not. So first one, probability of E. That is, E is the event, the card drawn is a spade. How many spade cards are there? 13. Therefore, probability of E is equal to 13 divided by 52. That is equal to 1 by 4. Right? Next, what is probability of F? F is the event, the card drawn is an ace. There are 4 ace cards out of 52. So 4 divided by 52. Probability of F is equal to 4 by 52, that is 1 by 13. Right? Next, we need to find probability of E intersection F. So what is the event E intersection F? E intersection F is the event the card drawn is an ace of spade. Okay? Because see, the card drawn is a spade. E is the event, the card drawn is a spade, and F is the event, the card drawn is an ace, right? Therefore, E intersection F, its intersection, that is, intersection is the card drawn is an ace of spade. Okay, so there is only one ace card of spade. Okay, therefore, here probability of E intersection F is equal to 1 by 52. Okay, now let's take probability of E into probability of F is equal to 1 by 4 into 1 by 30, that is equal to 1 by 52, that is equal to probability of E intersection F. Hence, E and F are independent events. Now let's go through second one. E is the event card drawn is black and F is the event card drawn is king. Okay. So what is probability of E? Here probability of E is there are 26 black cards, right? So therefore probability of E is equal to 26 divided by 52, that is 1 by 2. Right? Next is the card drawn is king, that is probability of F is equal to, there are 4 king cards, therefore 4 by 52. Probability of F is equal to 4 by 52, that is 1 by 13. Okay. Next, what is the intersection? E intersection F is the event, the card drawn is black king. Black king. So how many black king cards are there? 2, right? So that is probability of E intersection F is equal to 2 divided by 52, that is equal to 1 by 26. Right? Therefore, probability of E into probability of F, that is equal to 1 by 2 into 1 by 13, that is equal to 1 by 26, that is equal to probability of E intersection F. So in second case also, E and F are independent events. Third one, E is the event card drawn is a king or queen. F is the event card drawn is a queen or jack. So here probability of E is equal to, there are 4 king cards and 4 queen cards, therefore total 8. Therefore probability of E is equal to 8 by 52. That is equal to 2 by 30. Right? Okay. Then probability of F is equal to, F is the event card drawn is a queen or jack. There are 4 queen cards and 4 jack cards, total 8. So 8 by 52. Okay, that is equal to 2 by 30. Then what is the event E intersection F? E is the event card drawn is a king or queen, and F is the event card drawn is a queen or jack. Queen is the common, right? Therefore, E intersection F is the event card drawn is a queen. Okay. Therefore, what is probability of E intersection F? There are 4 queen cards. So, probability of E intersection F is 4 divided by 52, that is equal to 1 by 30. Now, let's check probability of E into probability of F is equal to 2 by 13 into 2 by 13, that is equal to 4 by 169. It is here, but here we have got probability of E intersection F is 1 by 30. Therefore, probability of E intersection F not equal to probability of E into probability of F. Therefore, in third case, E and F are not independent events. In a hostel, 60% of the students read Hindi newspaper, 40% of the students read English newspaper, and 20% read both Hindi and English newspapers. A student is selected at random. First one, find the probability that she reads neither Hindi nor English newspaper. Okay, so first of all, let's take the event. Let H be the event. Student reads Hindi newspaper. Okay, and let E be the event. Student reads English newspaper. Okay, then what is probability of H? Here it is given, in a hostel 60% of the students read Hindi newspaper. Therefore 60%, 60 out of 100, right? That is equal to 6 by 10, that is equal to 3 by 5. Okay. Next, what is probability of E? Probability of E is equal to, E is the event student reads English newspaper. It is given that 40% students read English newspaper. Okay. That is 40 divided by 100. That is 4 by 10 is equal to 2 by 5. Then after that, what is probability of H intersection E? See, it is given 20% read both Hindi and English. That is nothing but probability E intersection H, right? That is probability of E intersection H is equal to 20 divided by 100. That is equal to 1 by 5. Okay. Now, first question is find the probability that she reads neither Hindi nor English. Okay, that is probability of neither Hindi nor English. So Hindi, not Hindi. Okay, H complement intersection E complement, right? Or you can write probability of H complement E complement. That is nothing but H complement intersection E complement. Okay. So here that is equal to, here this can be written as probability of, it is not independent events, okay. Therefore here we have to apply another method, that is probability of H, apply the properties of complement of the sets. So H complement intersection E complement can be written as H union E whole complement, right. That is equal to probability of A complement is 1 minus probability of A, right. That is 1 minus probability of H union E. That is equal to 1 minus, what is probability of H union E? We have a formula. Probability of H union E is probability of H plus probability of E minus probability of H intersection E. We have all these terms, right? Substitute. 1 minus probability of H is 3 by 5 plus 2 by 5 minus 1 by 5. That is equal to 1 minus 3 plus 2, 5, 5 minus 1, 4, 4 by 5. That is 1 by 5. Therefore, probability of students read neither Hindi nor English newspaper is 1 by 5. See, second one, if she reads Hindi newspaper, find the probability that she reads English newspaper. How to find? See, here given, see, one event is already occurred. Okay, if she reads Hindi newspaper, find the probability that she reads English newspaper. We know that probability that she reads English newspaper is probability of E, right? But here it is given that she reads Hindi newspaper. Okay, so what is the probability? How can we write? Probability of E, okay, probability of E given H. Okay, one event is already occurred. Okay, that is, so from this we have to select. Okay, so here probability of E given H. Okay, that is equal to probability of E intersection H divided by probability of H. That is equal to probability of E intersection H is 1 by 5 divided by probability of H is 3 by 5. That is equal to 1 by 3. Now third one, if she reads English newspaper, find the probability that she reads Hindi newspaper. Similar question, right? So here one event is already occurred. So from this, find the probability that she reads Hindi newspaper. Okay, that is probability of student reads Hindi newspaper given that student reads English newspaper. Okay, that is third one. Probability of, we know that probability of student reads Hindi newspaper is probability of H, right? And here from this, that is, this event is already occurred. So given that English student reads English newspaper. Okay, so given probability of H given E, that is equal to probability of H intersection E divided by probability of E. That is equal to probability of H intersection E is 1 by 5. 1 by 5 divided by probability of E is 2 by 5. So it is equal to 1 by 2. The probability of obtaining an even prime numbers on each die when a pair of dice is rolled is dash. So here when a pair of dice is rolled, we know that there are 36 elements in sample space. There are 36 possible outcomes, right? So here number of S, that is number of sample space is equal to 36. And the probability of getting an even number on each die. See, here we know that even prime number, okay, we know that there is only even prime number, that is 2, right? So here what is the possibility? So let's take, let A be an event getting even prime number on each die. Okay. Now what is probability of A? What are the elements of A? There is only one possibilities, right? 2, right? Because there is only one even prime number, that is 2, and there is only one possibilities getting even prime number on each die, that is 2, right? So here only one element. This set A has only one element, there is only one possibility. Therefore, probability of A is equal to 1 divided by 36. Right? So, it is the correct answer. Two events A and B will be independent. If A and B are mutually exclusive, probability of A complement B complement is equal to 1 minus P of A into 1 minus P of B. P of A is equal to P of B, P of A plus P of B is equal to 1. P of A intersection B is equal to P of A into P of B. Okay, we know that two events A and B are independent if probability of A intersection B is equal to probability of A into probability of B, right? Then probability of A complement B complement, that is equal to probability of A complement intersection B complement, right? That is equal to probability of A union B whole complement, right? By the properties of complements of sets. So that is equal to 1 minus probability of A union B. That is equal to 1 minus probability of A union B is probability of A plus probability of B minus probability of A intersection B. Probability of A intersection B is probability of A into probability of B. Then 1 minus probability of A minus probability of B plus probability of A into probability of B. Okay, that is equal to 1 minus probability of A. Here let's take minus P of B outside. Okay, P of B outside, that is it is 1 minus P of A, right? Because we have taken minus P of B outside. Okay, so here 1 minus P of A, here 1 minus P of A is common. So 1 minus P of A into, take outside, so 1 minus P of B. So here 1 minus P of A into 1 minus P of B. That is probability of A complement into B complement is equal to 1 minus P of A into 1 minus P of A, P of B. It is the correct answer. And see, if A and B are mutually exclusive, A and B are mutually exclusive, then A and B are not independent events. Okay, because we know that mutually exclusive means here they are disjoint events, right? Their intersection is 0. Intersection is null set, right? So it is not correct. And what about this one? Probability of A is equal to, if probability of A is equal to probability of B, A and B need not be independent events. Okay. Then if probability of A plus probability of B is equal to 1, then A and B are complement events each other. Okay, they are complementary each other. Then correct answer is B.